Percubaan 1, 2, 3, 4, 5, 6, 7, 8. Okay, hello guys, welcome back to example 4.5. Okay, for this example, we require to use the initial condition, which is we use the RC circuit analysis. Okay, so here we have a RC circuit here. We have a resistor, we have a capacitor. Okay, this one the XT, and the value of R is 1 kilo ohm. The value of capacitor is 200 millifarad, and this is the output, which is YT. So here, use the Laplace transform to find the voltage across the capacitor YT for the RC circuit as shown this figure. In response to apply the voltage, which is the ST. Okay, this one the applied voltage, which is ST 3/5 exponent negative 2t ut, and the initial condition, which is y 0 is equal to -2. So this one the input, and this one the initial condition, this one the RC circuit. So what is the step 1? Okay, for the first step, okay, we require to use the KVL. Do you still remember what is the KVL? So the KVL means here this power source voltage we minus with this voltage across the resistor and minus with the voltage across to the capacitor. So how we want to write? So XT minus with the R. So do you remember how to find the V is equal to IR? So we have the R and the value of ICD dt YT minus with the YT voltage here and equal to 0. Okay, according to this one, we want to separate the value of XT and the YT. Okay, so XT equal to this one negative, bring to the right side, we will be R C D dt YT plus with the YT. Okay, so we want to make the denominator same, so XT here over RC. So this value we want to eliminate, so d over dt YT plus YT over RC, and then we replace this value, the R and C here, which is 1 kilo ohm and 200 millifarad. So XT R is 1k times to 200 milli minus equal to d over dt YT plus YT over 1k times 200 milli. So 1 over 0.2 is equal to 5 XT equal to d dt YT plus 5 YT. Okay. Okay, according this one, we can see here, for this one we can apply the differential property. Okay, for d over dt YT, so d over dt YT. Okay, so d over dt, if you refer back to the Laplace property, d xt, we're going to Laplace, so s x s minus with x negative 0, 0 negative. Okay, according to this one, we want to replace for this one. So let's we solve for this one. Okay, so here we s ys minus with the y0 negative plus with 5 ys equal to 5xs. So for this one we convert this one and convert to the s domain and solving for the ys. So here we try to solving for the ys. Solving for ys. So here ys s plus 5 minus y0 negative equal to 5 xs. So y s equal to 5xs plus for this one y0 negative minus with the s plus 5. Okay, so here also same with the s plus 5 xs plus y0 negative. Okay, you got it? So here we already have the value of initial condition, which is y0 negative is equal to negative 2, and how to get the value of xt, we require to convert, to transform the value of xt equal to xs. Okay, so after we convert, we can get the value 3 exponent negative 2t over 5. So here this is the value of xt, ut, and after we transform it, we get 3 over 5 plus s plus 2. Okay, so this is the value of xs. Okay, so we just replace for this one, and xs we already have the initial condition, we already have, so ys 1 over s plus 5. Okay, so 5 times 3 over 5 s plus 2, and then plus negative 2 of for the initial condition. Okay, and then for this one we can eliminate here. So this is the final value, which is you can times here. So 3 over s plus 5 and s plus 2. Okay, you got it? And this one we also require to times here, so negative 2s plus 5. Okay, get, and all of you get for this one. Okay, okay, actually for this one, if you know here, we require the partial fraction. Okay, we require the partial fraction. Okay, so let's check it out. Okay, this is for the next step. So we use the partial fraction, so we can pull out here s plus 5 and s plus 2 equal to a. Okay, you can refer to the partial fraction table. S plus 5 and plus B S plus 2. Okay, so same step. So we require to eliminate the denominator. So 3 S plus 5 S plus 2. So for this one, S plus 5 S plus 2. So we require the S plus 2 here. And for this one, for the B, S plus 2 and then S plus 5, we require the S plus 5. Okay, so for this one, we can eliminate for this one. So A is equal to S plus 2 and plus B S plus 5. Okay, according to this one, we multiply inside the bracket. Okay, so AS plus 2A plus BS plus 5B, okay, is equal to 3. So we compare the left side and the right side. So here, this is the AS, okay, AS, and for this one there is a BS, and this one for the real integer here. So A plus B S plus, okay, 2A plus 5B is equal to 3. Okay. Okay, for this condition, so we look back here. For this one, for the right side we have S, and for the left side we not have the S. So A plus B, okay, is equal to 0. Okay, this is number 1, and 2A plus 5B is equal to 3 is then number 2. So here we want to find value A and B. Okay, according to this one, the value of A, okay, A is equal to negative B. Okay, so A is equal to B, so we can write as the number 3. Okay, equal to number. Okay, and then for the next one, 2A, we can use the equation number 2. So 3 insert to number 2. Okay, insert to number 2 here. So 2 negative B plus 5B equal to 3. So the B is equal to, okay, equal to 1. Okay, and then we replace back to the equation number 3 to get, so the value of A is equal to negative 1. So we already get the value of A and B. A is a negative 1, B is equal to 1. Okay, so we replace back to the first equation, which is the value of A, thus 3S plus 5 S plus 2. The value of A is negative 1, S plus 5 minus 1 plus y with 1 over S plus 2. Okay, so we got this value. You require to put back for the previous equation. Okay, So this is the previous of ys. So we write back. So ys is equal to -1 s plus 5 plus 1 s plus 2. Okay, this is the previous ys. So for this one only for the partial fraction, and minus with the 2 over s plus 5. Okay, according this one we got the value 1. Okay, this one minus this one, so 1 over s plus 2. Okay, for this one we get a negative 3 s plus 5. Okay, this is the ys. So we require to convert back to the yt. Okay, so because we want to find the value yt according this one. Okay, according this one you can refer to the Laplace table. Okay, you can refer to Laplace table as the previous exercise we have been done. So yt equal to negative 2t ut. Don't forget this, the ut minus with 3 exponent negative 5t ut. Okay, don't forget this one. So hashtag for the final answer. Okay, this one the final answer. Now you have been done for the unilateral Laplace transform. I hope all of you can understand step by step for the every Laplace transform calculation. Okay, for this one you have already done to learn about the Laplace transform, inverse Laplace transform, using the partial fraction, using the property of Laplace unilateral Laplace transform. Okay, I hope all of you can make this one as an opportunity to score my test and assignment. Okay, if you have any question, don't forget to WhatsApp me. Okay, don't shy. Okay, bye, that's all.